Hi, welcome to today's lesson on solving graphing inequalities where the variable is on the right side or there are variables on both sides, and then we'll get to the really scary ones, the special cases that are a little tricky to understand, but we'll really look at them. So let's start with, what do you do if there's variables on the right? Everything we learned in our last video says get the variable on the left-hand side. What if the variable is on the right-hand side? So what if it were something simple like 4 is greater than or equal to 3x minus, oh, let's make my life easy, let's make it minus 5. So what do I do here? The variable is on the right, and maybe it's because of the situation, because of the scenario, somebody came along and said, well, 4 is bigger than all of that stuff. 4 is greater than 3x minus 5. Okay, and that just, remember, it has to do with perspective. Sometimes someone will say, this comes first because they will. Remember, if you remember from a couple of lessons ago, I say I am older than you or you are younger than me. It's the same piece of information. It just matters who's mentioned first, perspective. The great thing about this is you are allowed to pick this up and absolutely just rewrite it in reverse. I don't want the variable on the right, I want the variable on the left. So I'm going to pick this up just the way it is, and I'm going to move it over here. When I do that, I have to pick this up and I move it over here. Now what do I do with the inequality? If it were an equal sign, it wouldn't matter, right? Because in an equal sign, you have two things that are equal. If they switch sides, they're still equal. Well, what do you do with an inequality? Well, just what you'd think you'd do. The alligator wanted to eat the 4. The alligator still wants to eat the 4. It hasn't changed. It's like a teeter-totter now. Instead of a balance where things are level, what if they're like, hey, this one's heavier than this guy. If I tell you guys, switch sides, it's not like it suddenly does this, like they'll suddenly do this. It's this heavier guy is now here and the lighter guy is still here, and now this one's still further down. So this changes absolutely nothing in how we solve it. We just have to know that when we turn the inequality around, we have to turn the sign around because the alligator wants to eat what the alligator wants to eat. And then we still go through the same litany of steps, right? We're still going to do the parentheses, we're still going to combine like terms, we're still going to, and we've done, this is the key one, is we've gotten the variable on the left. Now, in truth, we could have done this first, okay? Now, when we see them with variables on both sides, this is kind of where we're going to want to do it. But we could have done it first. There could have been a parentheses there, and we still want to do this here. Or we don't have to. We can do it as long as we do it somewhere through the problem. We can even do it at the end. We can even do it at the end. We can do it at some point during the problem. Let's get the variable on the left-hand side. Because now we're going to do the sad me part. So we're going to add the 5 to both sides. We get 3x is less than or equal to 9. We're going to divide by 3, and we get x is less than or equal to 3. Now I did say we were going to graph it, so we are going to graph it. So here we are at 0, 1, 2, 3. And when you're graphing, you don't have to count out every number. Okay? Show me where 0 is, count out some spaces, and then say, hey, here's 14. I don't know. 3, I can count every space. 3, less than or equal to means it's a closed dot. Remember from our last lesson, we asked what kind of a dot, open or closed. This is a closed dot. And then which way do we shade? Now we are looking at it correctly. This is all the numbers less than. Less than is to the left. Less than left. And again, if I'm not sure, if I want to be sure, this is where I would, again, check a solution. And what solution I always check is 0. If it's supposed to work, make sure it does. If it's not supposed to work, make sure it doesn't. So I go back up here and I say, if I put a 0 in the original equation, does 4, is that greater than or equal to 3 times 0, which is 0 minus 5? Is 4 greater than or equal to negative 5? Well, yeah, it's bigger than negative 5. It absolutely is. So sure enough, that's the right graph. Okay? So we now have this new task, okay, and that is make sure the variables are on the left-hand side when solving an inequality. Does that mean you have to? No. Will it make it easier for you? Absolutely. Absolutely. It also makes it easier to read, easier to graph, easier to maybe understand, but it is not, doesn't have to happen. I could have I could have ended this with, it could have looked like this. 3 is greater than or equal to x. And what I would have said then is, okay, well, if 3 is bigger than x, then x has to be all the numbers smaller than 3. See, it just requires me to do an extra step of thought, that if I know that 3 is bigger than x, then I have to remind myself, oh, that means that x is less than 3. But if I've gotten it where the variable is on the left, it's inherently built into my answer. When I say x is less than or equal to 3, then I know I'm getting all the information all at once. All right? That's what to do when you have the variable on the right-hand side, and only the right-hand side. So if you have the variable on the right-hand side, at some point during the problem, move it over to the left by turning the whole thing around. Okay, putting whatever's on the left now is on the right, whatever's on the right is now on the left, and the alligator changes and faces in the other direction. Okay? Now, what if we have variables on both sides? What if we have something, let's just make it easy. Let's go 5x minus 2 is greater than or equal to 2x, let's go minus 8. Okay. What do I do now? I have variables on both sides. Well, I would still look for parentheses if I had any. I don't have any. If I had any like terms to combine, I would still combine my like terms. I would still, if I had them, combine like terms. And now I have this step, getting the variable on the left-hand side. Okay, that just means I'm getting rid of this one. No matter what it is, I'm going to get rid of it. In this case, I'm going to subtract 2x from both sides. That gives me 3x minus 2 is greater than or equal to negative 8. And now I'm down here in the sad me part. So I'm going to add 2 to both sides. 3x is greater than or equal to negative 6. I'm going to divide by 3. And I start to see the negative, so I wonder, am I supposed to turn the sign around? But I listen. What did I do? This is why the process is more important than the answer, because I ask you, what did you do? And you say, I divided both sides by 3. And I listened. I heard divide, and then I heard by, and then I didn't hear the word negative. So no, I'm not turning that sign around. I know my answer is going to be negative, but that's okay. And then I can go ahead and graph it. So here I am at negative 2. Again, there's a line under it, so it's a closed dot. All the numbers greater than, greater than is to the right. So again, I'm going to go all the way to the end and the arrow. And again, I can check 0 and make sure it works. I think I should do one there where 0 doesn't work, just so you can see what it looks like. But again, I go back all the way up to the top, and I would say, all right, 5 times 0 minus 2 is greater than or equal to 2 times 0 minus 8. Well, 5 times 0 is 0, minus 2 is negative 2. And 2 times 0 is 0, minus 8 is negative 8. Is negative 2 greater than negative 8? Yeah, it is. I mean, I'd rather owe $2 than owe $8, so this is the bigger number. It's further to the right than on the number line. Negative 8 would be out here somewhere. That actually is going to help us understand the special cases, which I'm going to talk about in a few minutes, is understanding that this check worked. Okay? So let's remember this check, that negative 2 is greater than negative 8 actually works. And what if, okay, I want to do one more where the answer is not going to be, where 0 is not going to work. So let's do, again, one with variables on both sides. Let's even make it a little harder. Let's go 2x minus 4 is less than, let's go 5x, nope, let's make this a greater than. There we go. Greater than 5x. Oh, let's make my life easy. Let's go plus 2. Okay. So again, I go through my whole litany here, looking for the parentheses, don't see any. Looking for like terms, don't see any. Getting the variable on the left. So that means I'm going to get rid of this variable. I'm going to get rid of it by subtracting it. So I'm subtracting 5x. 2x minus 5x is negative 3x. Okay? So I've got the variable on the left. Again, the sad me, I've got this minus 4, so I'm going to add 4. And then I'm going to divide both sides by negative 3. And I heard all the words there. I divided both sides by negative 3. So when I do that, I'm going to turn this inequality sign to face the other direction. And now I'm ready to graph it. So here I am, here's 0, here's negative 1, here's negative 2. There's no line, so that means it's an open dot. Remember what kind of a dot? Open. And it is less than. Less than is, again, to my left. And now if I've done this correctly, 0 better not work, because I didn't shade it in. I didn't say it was part of the solution. So I'm saying it won't work. So when I go back up here and I plug it in, 2 times 0 minus 4. Is that greater than 5 times 0 plus 2? Well, 2 times 0 is 0, minus 4 would be negative 4. 5 times 0 is 0, plus 2 is positive 2. Is negative 4 greater than 2? Absolutely not. Have money, owe money? No, this is bigger. So this one didn't work. That's why I know 0 is wrong, which is why it's not shaded in, which tells me that that is the correct answer the way I've shaded it. And these two situations, this one and the previous check that we did a minute ago, is really going to help us understand these special cases. And these special cases are weird. Students struggle with this all the time because the answer is something that, I don't know, they're not as comfortable with as they would like to be. So let's make sure we understand this. If the variable is on the right, we can simply turn the whole problem around and face the other direction. Move everything that's on the right over to the left. Or you know what? Let me just, in fact, let me show one more. I won't even check it. I won't even graph it. I just want to show, if you remember back to that original problem was 4 is greater than 3x minus 5. That's what the last one looked like. You know what I could do? I could just subtract 3x from both sides. But there's no x over here. So there's an imaginary 0 right there, which gets me negative 3x. This is a positive 4. And now I've moved the variable onto the left-hand side. Now it's easier to just flip the whole thing, but you could have done it this way. Then you subtract 4 from both sides and divide both sides by negative 3. And when I divide by a negative, I'm going to flip the sign around. And if you remember back, if you rewind this video, you can see that the answer was x is less than 3. When I picked this up and moved it over there and flipped that all around, it was a lot faster to just flip the whole thing and then start than it was to subtract the 3x and then continue from there. But you could have done it. It would have worked. Okay? So again, there's not only just one way to do it, but there are multiple ways that the same thing plays itself out. Okay? Now, special cases. I'm even going to erase this. Okay? The special cases. Okay, there are really two types of special case. Okay, let's look at what one of them looks like and then I'll sort of mention what they mean. And it's one where you see, they almost always love to do something like this, where we'll go like 4 times x plus 12. Let's make it x plus 2. Is less than or equal to 4x plus 8. Well, after you do the distributive property here, because that's the first thing I'm supposed to do, is you get 4x plus 8 is less than or equal to 4x plus 8. Now, I'm sure at this moment you realize, hey, those are exactly the same thing. But let's take it one more step further so I can really explain what's going on. If we get rid of the variable from the right-hand side by subtracting 4x, we don't have any variables left. And we get x is greater than or equal to 8. Is that true or not? And that's where the special case kicks in. So when you have no variable, that means when you've decided to get rid of the variable from one side, it also got rid of the variable on the other side. Meaning you have exactly the same amount of variables on both sides. Remember, it's almost like you have a balance, right? And you've decided, oh, well, there's some things I'm supposed to weigh on both sides, and if I take one off of each side and one off of each side and now I have none left? I have this statement, a is less than or equal to 8. So if when you have no variable left and a true statement, that's actually what they call this. This is a mathematical statement. 8 is less than or equal to 8. When you get rid of the variables and you have a true statement, the answer is all real numbers. Heck, even imaginary ones. So let's just take that out. Let's just call it all numbers. All solutions, infinite solutions, I think sometimes they refer to it as. Infinite solutions. So all numbers or infinite solutions. Meaning, it doesn't matter what x is because there's exactly the same number of them. Okay? If I tell you is 2x is equal to 2x, right? I don't know what x is, it doesn't matter, they're the same. It's like, again, it's like fate, it's like money that you don't understand. It's foreign money. You don't know I don't know what a rupiah is, but I know if I have 2 of them in my right hand and 2 of them in my left hand, they are the exact same value. Even if I have no idea what that value is, I know that if I have 2 of them on one side and 2 of them on the other, it doesn't matter what they are, they're going to be equal. So it doesn't matter what you tell me they're worth, these 2 hands are always going to be worth the same amount. It doesn't matter what you tell me x is going to be worth, these 2 inequalities are always going to be equal. They're always going to work. Okay? So that's one of the situations. Now watch this. This is all it takes for this thing to change. Same situation, except we're not going to be equal to. 4 times x plus 2 is less than 4x plus 8. So if I take that off, when I subtract, is 8 less than 8? No, we just said that. It doesn't work. So when you have no variable, same thing, and a false statement. Okay? The answer is no solution. It's weird. So the answer is that there isn't an answer. There is no answer. There is no value for x that will ever make that work. Okay? So there is no solution. So the solution is, that is the solution. That is the answer to the question, that there is no solution. There is no value that will ever make that work. And I'm telling you now, there are going to be other times when you're in other math classes where no solution is a completely legitimate answer. It is what you're looking for, and you will prove that there's no answer to this problem. And that actually is the answer, that there is no situation where this works. Okay? And for our purposes, this is when it happens. When you're in the process of solving, when you get to the step that says get the variable on the left, and you're eliminating the one on the right, and when you do that, it also eliminates the one on the left. It leaves you with a statement. And if that statement is false, then your answer is there is no solution. So the 2 special cases are either everything works, no matter what, or nothing works. And those both happen when you eliminate when both variables are the same on both sides. Okay? Now there's something called a compound inequality. We are not ready for that. We're not hitting that at all this year. I might talk to you about it in office hours or in class if someone asks me, but it is something that you will work on in high school next year. Okay? So, move the variable onto the left, understand how to graph it, and know what to do when there's no variable at all. Otherwise, I will see you guys in office hours or in class.